Hey, here's a video for, this is the 2010 AB free response questions, number 5. I had a very geometric looking graph of a derivative here, so I'm thinking probably going to be doing some area, and let's see what they say about this. So we've got this g function. That's not what we're looking at. We're looking at g prime here. The function g is differentiable on the closed interval and satisfies. So this is key here. G of 0 equals 5 for fundamental theorem. Graph of y equals g prime of x is given here. It's got a semicircle and 1, 2, 3 line segments. All right, so it looks like we're right into the fundamental theorem right out of the gate here. So fundamental theorem says this, right? We just have to pick the right numbers to go here and here. So if I want g of 3 and I know g of 0, I'll do that, right? So let's see, the area from 0 to 3, this is a quarter of a circle, and the area of the whole circle with radius 2 would be 4 pi. So this slice of it right here has an area of pi, and so with this one over here, of course. And this, if we're going from 0 to 3, this triangle right here has a base of 1 and a height of 3. So 1/2 base times height would be 3/2 for that. So this is pi plus 3/2. It's all positive area, and I'm going from 0 to 3, like in the right direction. So it's all good. And then g of 0 is 5. So that means g3 is equal to pi plus 3/2 plus 5. And you can leave it like that. That is totally fine if you don't feel like doing any more math. If you do feel like doing a little bit more math, then you could simplify it to that. Alright, we're also supposed to find a g of -2. So to keep things going in the right direction, I'm going to go from -2 to 0. Alright, so this, some more geometry. Let's see, from -2 to 0, that's pi. Oops, I went that a little too far down there. Pi. G of 0 is 5 minus g of -2. So just rearranging a little bit, g of -2 is equal to 5 minus pi. All right. Part B. Find the x-coordinate of each point of inflection of the graph y equals g of x on the interval, and explain your reasoning. Well, inflection point is where the second derivative changes sign, and if I'm looking at a graph of the first derivative, then the second derivative is the slope of this. So that means that the sign of the second derivative is just whether this is increasing or decreasing, right? If g double prime is the slope of this, this has positive slope, then negative slope, then positive, then negative. So inflection point where g double prime changes sign, or in other words, where g prime has a maximum or minimum, because that's where g prime goes from increasing to decreasing or vice versa. So that happens at x equals 0, 2, and 3. All right, part C. The function h is defined to be this. Find the x-coordinate of each, there's my light up, my fancy light up pen. Find the x-coordinate of each critical point of h and classify each critical point as the location of a relative maximum, minimum, or neither, and explain the reasoning. Okay? So if I want to find critical points of h, that's where h prime is equal to 0 or undefined. So h prime is going to be equal to g prime of x minus x. All right, I take that derivative. So h prime of x equals 0. That would be 0 equals g prime of x minus x. That's going to happen when g prime of x is equal to x. So there's different ways to think about this, like where is g prime of x equal to x. I'm going to go ahead and just graph, like I have the graph of y equals this right here, and then what would the graph of y equals x look like? Well, that's just a line that goes through the origin with a slope of 1. So where do these two things intersect? That's where they're equal to each other. So they intersect right here and right here. So h prime of x, that's a 45-degree angle. You got to do a little bit of math here to figure out if that's a radius of 2, then these two sides must be the square root of 2. Oh, a little bit of geometry there. So h prime is equal to 0 at x equals the square root of 2 and x equals 3. And if we want to be able to say whether it's a relative minimum, maximum, or neither, then we have to see, does h prime of x change sign or not at each one of these things. So could make a little sign chart. It's h prime, and I got the square root of 2 on there, and I got 3 on there. So we could see, we could test, for example, something that's less than the square root of 2, like 0, for example. If I plug 0 in here, and g prime of 0 is 2 minus 0 is positive. And then if I plug in something, square root of 2 is like 1.4 or whatever, so I could plug in 2 is in between these. So if I plug in 2, then g prime of 2 is 0 minus 2 is negative, and something bigger than 3, like, I don't know, 4 is bigger than 3. So plug in, actually let's plug in 4.5, because that's got a nice value, because g prime of 4.5 would be 0, minus 4.5 is negative. So it looks like we have a maximum at x equals the square root of 2, because h prime goes from positive to negative, and neither at x equals 3 because h prime does not change sign. And that is the end of that story. What a good story it was.